All right, so we are given an improper integral, and we're asked for what value of k, if any, is this integral equal to 1? So basically, what's going to happen here is I'm going to go ahead and I'm going to do work without bounds. I mean, it is multiple choice, so nobody's really going to care. But I'm going to do the work without the bounds and see what would happen if I integrate this thing, right? So this is definitely, this is pretty likely parts, right? Because if I tried u sub, right, if I try u sub here, I wouldn't end up with an x out here as part of the derivative. So this is probably parts, right? So using Liat, right, to suggest what I pick as my u, I see that algebraic expressions come before exponential expressions, so I'm going to go ahead and make the thing that I derive, aka the thing I'm going to call u, this kx, and make this my dv, right, the thing I'm going to integrate. Now the reason I'm doing it like it's the shortcut is because kx is eventually going to differentiate away to 0, right? It's going to be kx, then it's going to be a k, and then it's going to be a 0, right? This starts out as an e to the negative 2x, and each time I integrate, I'm going to have to divide by a negative 2, right? So this will end up being a 1/4 e to the negative 2x. And then my shortcut says that it looks like this, right? This would have a positive, and then this has a negative, right? So what's going to happen is I'm going to get that this integral is actually, from one bound to the other, a negative k over 2x e to the negative x, 2x rather, and then a negative k over 4 e to the negative 2x, right? And then it would disappear in the last one, right? So, and I know, so now if I go back and look at my bounds, right? When I look at my bounds, I know that it's from 0 to infinity. So let's go ahead and cheat now and include our bounds, right? So I'm going to actually steal this work that I did. I'm going to move it up here. Now, again, I'm going to make the argument that because it's multiple choice, I can get away with doing a lot of stuff that I can't on a free response, right? So for instance, I could basically cheat and treat infinity like it's a bound. You're really not supposed to do that. You're supposed to use the limit as some bound approaches infinity, but you could probably get away with it because it's multiple choice and no one's looking. So I'm going to say that this is the limit as b approaches infinity from 0 to b, right? Sorry, it's a b, not a 1. Okay, so if I were to plug these values in, right, I'm going to get, the short version here is that, see how this is a negative infinity? That's going to be a 0. It's going to be a 1 over an e to an infinitely large power. So basically, when I do b, right, it's going to disappear. And if you see that ahead of time, it's great. And if you don't, that's also fine. But this is going to be a negative k over 2 b e to the negative 2b minus k over 4 e to the negative 2b, right, this thing, minus, and then a bunch of me plugging in 0. Well, when I plug in 0, this whole term gets knocked out because of the x. But this is going to become a negative k over 4 times a 1 because of the e to the 0. So all of these, when b approaches infinity, because this ends up being an e to the negative infinity, this whole thing zeroes out. And I end up getting that this whole thing is really just a k over 4. Well, they told me that k over 4 apparently is supposed to equal 1, so k must be 4, and my answer is C. That is not a short problem. That's a pretty tricky multiple choice problem.